Okay, hi guys. Welcome back to the brand new session of operating system programming concepts. And for today, let's investigate in a topic that is called pipe. And let's see the magic of cell programming today. All right. So, okay, let's begin then. So, what is a pipe? And what do you mean by pipe, or what is this pipe used for? And as I have already discussed and used the pipe commands shortly, but for the in a conceptual point of view, right? So today we'll use a pipe in a C programming language, okay, to and see how programmatically how can we pipe by using C program, okay. And for this pipe is used to connect a data flow for one process to another. Actually, I have already told you guys that pipe is something like it's used for inter-process communication. It communicates, okay, from one process to another. So it's passing data from one process to another process, right? So here it goes like from command one, that is process one, you pipe, okay, you pipe with this special symbol that is a straight line, something like it's a and this is a pipe command, and you command to second process, that is command 2. And the standard output from command 1, the standard output, okay, is fed to command 2. That means so the input of command 2 will be the output of command 1, right? So here it goes and works like this, and the magic is something like that. So what is a pipe call then? Today we are going to use this pipe call uh, to provide or to show how the inter-process communication works. So this pipe call provides the means of passing data between two programs. So this is the syntax of using the pipe call. So what you guys have to understand is like the parameters are passed as a file descriptors, and these file descriptors are of array size 2. Alright, and it's return an integer. That means on failure it is going to return a -1. Okay, so before, here is a particular example for using the pipe. So before showing about the pipe, let me just show you the manual of pipe. If you go and check out the manual of pipe, you will see the certain situation that this pipe uh, is included in a Unix standard header file. Alright, so it has something like I have already told you, always two file descriptors are provided, and it helps in inter-process communication. And right, the return value is 0 on success, whereas error on -1. Alright, so that's it. Here is also some specific example given in this manual. You guys can go through this example by yourself. And for me, okay, right now I will show you an example of how to pipe across a fork. So here what you are doing is you are trying to pipe across a fork. So as you guys already know, that fork is something that is used for creating a process, right? New child processes. So here what we do is we create the fork, then we try to pipe, okay, among these two processes, that is child process and the parent process. So we try to pipe, that means we try to process, like we try to communicate with this process. Alright, so all these standard libraries are included. As you guys already know, you need the standard input output, standard library, standard Unix standard header files, string header files, and what is this, like you define the variables here. And as you guys know that we need file descriptors, and we have defined this file descriptor, file pipes of array size 2. Also we define some constant characters, alright, and we define a character buffer, and here I have used a special constant, that is buff size. And buff size is actually that is chosen by each system. Okay, each Unix is like, for example, Unix system chooses its own buff size. And why does it choose its own buff size for the buffer? Because it helps to make the input and output very efficient. Okay, just to make input and output, because right now we are working with input and output, right? So it helps input and output very stable. And this is the situation. Now this is the define the PID, process ID, and the memset. Okay, let me show you. Is the manual of memset fills the memory with a constant byte. So the memory is buffer. So what it does, first n buffer, n bytes, okay, of the memory. So size of the buffer of this one that we have defined, okay, fills this size of n bytes of memory area pointed to by s. So s is something like this. So this will be a pointer. Okay, this is pointing to the size, and the size of this will be filled, okay, with a constant byte of this size. Alright, and it is filled right now. The constant byte field is the empty number, so the constant byte is C. So this is a null, so it's something like a empty line. So it's a okay, that's it for the memory set. Now let's check the situation. Now what we have done is we check if the pipe function, it is like this system call with this file descriptor pointer as a passes a parameter equals to 0. That means on success what we do is like we try to fork, and we also check if the fork is -1, that means it's also the error fork, right? Fork failure. Whereas if the fork is 0, that means the child process is created. So inside the child process what we do is this read from the pipe. So what we do is we read from the pipe. So the pipe defines two file descriptor. One is taken here in this read block. Okay, so here what the read does is read system like this function. What it does is reads the block until the data arrives. So this reads of maximum buffer size buff C's and inside the buffer. So you can also check out man of read here, and what it does is reads from a file descriptor. As I have already told you before, the file descriptor was provided here, right? And starting from this buffer, okay, of size this count reads up to these bytes. Alright, so and it is reading, and now it just reads dash bytes. It shows how prints the statement that it is reading dash this number of bytes that is read by this process. Okay, this data process it returns an integer value of how many bytes it has written, and so exit, the child exits now. And lastly, in the parent, what the parent does is like it takes the second file descriptor from the pipe, okay, and it also just write the number of bytes, okay, to a pipe. So this is the situation how like of using the pipe system call. okay, to do inter-process communication among child and parent. All right, this is a simple example just to display about how we use pipe across a fork. Okay, after that, now let's see the magic of cell then, and also let's investigate in this cell programming language. And cell is a program that acts as an interface between you and a Unix system, right? Between you, it's it's you and the Unix system, this Unix operating system. In between you and the Unix operating system, there is a mediator or a middleman who is the cell, which talks, like it acts as like it's a telephone. Okay, so you can communicate with, as the medium is the telephone, you can communicate from one person to another person. You are the first person, you want to communicate with Unix, that is the second person, and the mediator is a telephone or your cell phone. Alright, and this cell phone is a cell, for example, just as a mode of thinking. And the most popular Unix cell system is called Bourne's Again cell, that is Bash. Okay, just check out the manual of Bash. What you see is all the documentation that is provided for GNU Bourne Again cell, that's a Bash, and everything, the options are provided, the documentation, the arguments, invocation, definitions, okay, the reserved words, everything is provided here, or the list. Alright, the commands used, and just I strongly recommend you guys to go through this documentation by yourself. And okay, so how do we create the script then? Yes, to create this script we use some text editor, and the most used text editor in Linux is a gedit. So I am also using gedit to create my bash script. Okay, so while creating a bash script, okay, let's check out. I have already created yes, so test the assets. Okay, let's remove this. Okay, let me create now gedit. This is my text editor. Now let me create a new cell file, that is test the assets again. So this is a new file that will be created. Alright, so what I do is right now I will just provide you a simple this cell script, and okay, it's going to echo the first parameter and similarly like this. So what it does, like the comments, you guys have to understand that comments start from this hash tag. Okay, but this first line comment is a special comment, and it is used for a special purpose. And what is the purpose of this hashtag, like the first command, that is this one, is that this has not, okay, tells the system that bin slash bash, this okay, it tells that the program must be executed from this file. Okay, so the path is provided here. So the path is this. You have to, while you execute any kind of cell like bash programs, the execution starts from here. So this tells the system, okay, so this is a comment to the system. Actually, this is not a comment to the user. This is a special comment that is used for the system to notify that the program has to use this path, that is bin slash bash, to execute this file, and this is a particular bash file. You know, the syntax of bash is .sh. Alright, Okay, let me save this and let's close this. Now the second question is okay, let me just reduce this. Now how do we make the cell executable then? To make the cell executable, you have to just, the magic is just like you have to change the mode. So change the mode means you just add the permission to your script and you add the permission to execute. So just change the mode, add the permission executable to your script name is test.sh. So suddenly what happens is like your test, it changes the color and it becomes the executable file, right? So what you do is just to execute, you guys already know that the same thing is done here. Look, and it just printed out some situations here. That means the file name, the executable file name ./test.sh, right? This is the first parameter. This the $# is the name of the, we'll go through it. These are all the environment variables, okay? So how do you use the variables in the cell then? To use the variables, the magic is like we use it when we create it. We create the variables when you use it. Okay, so whenever you do not need to declare like you do it in C programming language. All right. So what we do is we create them when we first use them. So by default, all the variables are considered and stored as a string. So this means like even if you assign like numericals like here, okay, what the cell does is cell will just convert them and just use them. So in whatever form it will be used. It is the decision of the cell to use it, convert them and use it. But all the variables are just considered as strings in cell. Alright, so here it goes. So this is the second example. I will just try to also just this. Okay, this program is copied here. Now let's save it and just execute it. Salutation command not found. Okay, look. Okay, you know why this is happening? Because you guys have to always understand one situation. Like whenever you use this variable, you have to just like avoid this kind of situation, the space between these values and a variable. Alright, and also avoid this kind of situation here, the space. This space must be avoided. Alright guys. So alright, right now it's working. Hello is printed. Look, salutation was assigned with a variable value that was hello. So right now everything is working well, right? Also, yeah, let me do it also here. Okay, so that was the situation. So 7 plus 3 was also printed out here, right? Now it's just echoing because as I have already told you before, all the values are taken as a string, so it just converts and just print it back, echoes it back. It is not perform the like the arithmetic, right? It did not add 7 plus 13 equals to like 20, right? It did the arithmetic part. So it's just like converting and just displaying it. It's not using it. So to do the arithmetic, okay, you guys have to just use the expression, okay, that we will do later on. And okay, now let's check the situations like there are some kind of quotations you guys have to understand. Like for example, as you have already seen that here I use the quotation, right, to specify this string. Why didn't use the quotation here, right? So let's check out the situation, like what happens in different situation of quotations, like here as I have provided here in this particular situation. So what happens, okay, so if I use a double quote here, this is string the variable, and when I echo in a different situations, like if I just use this one single quote, or this like black space before a variable, if I use double quote, if I do not use quotation, so what happens, okay, is like what happens is for a single quote no substitution will take place, alright, whereas this black slash is going to remove the special meaning of this dollar character. This dollar character is going to just like notify the cell that this is a variable, right? But it will now it will just remove the specification that is a variable, whereas there is a double quotation, and also there is a without a quotation, the variable without a quotation. So save this, close it, and let's execute right now. Yeah, there are three situations, right? So hello world was this, my var has a value that is high there. So this at both this situation, whenever you use you don't use any quotation, or you just use the quotation, what was done is like it replaced the variable was replaced by its value, and the value was high there. But in echo it was working well, that it printed out also hello world. But in the situation like single quotation and the black slash, so no substitution took place, okay, it did not replace the original value of what it should have been, right? So this was the situation. So this is just for you guys to know, to understand that it depends on what kind of quotation do you use. So always be careful while using the quotation. Alright, so with this quotation, let's begin our environment variable then. So this environment variable was I was just planning to give you before, right? Like to make you understand like what is this environment variable that we are using in cell. What is the cell's environment variable? What is the environment, and what are the variables that are used by this cell? So this is the specific things that you guys have to understand. And usually what is for investigation, if you start investigating, what you find is like when a cell script starts, alright, so some variables are initialized and from values in the environment. So there are some values already existing in this cell environment, and these are called already existing like values that must be taken from the cell are called environment variables. And if you go and check out this situation, okay, let's just print out and see by ourselves like what is this situation. Okay, so yeah, first I am trying to just echo out $home. So what is home? Home is a directory of a home directory of a current user, whereas $path is a colon separated list of directories to search for the command. So these are all the environment, these are all from the environment variables. These are taken directly from the C like the cell itself. Whenever you just like try to execute the cell programming language, this will already be initialized, these values. And PS1 is a primary and secondary command prompts. Okay, so this is P1, P12, whereas IFS is an input field separator. $G is the name of the shell script. Is the number of a parameters passed. Okay, so dollar is the process ID of a shell script. So we'll see what is going to happen. Okay, so just execute. Yeah, you see three kind of situations here. Now is a number of the home path, home directory is this one, and the colon separated list of directories are this one. You know, these colon separated directories are here, like this is colon here, and here, and it's a separated directories for to search for commands. So all these colon separated directories are given in a in order or level. Okay, level of search. And primary and secondary command prompts are 0. Okay, there is null, and whereas input field separator is also null, and the number of shell scripts is also, and the name of shell script is this one, the executable file that I used, whereas number of parameter passed are 0 and the process ID is 7207 lastly. Alright, so this was all about this environment variable. Now what are the parameters variable then? So okay, let's also check this situation. Parameters variables are not the environment variables, but these are the variables that are passed by the user whenever you pass any kind of parameters, then these are the parameters variables are also there. Okay, let's just alright, so execute it. You'll see you do not see anything, okay, because you did not pass any kind of parameters. So but when you pass parameters like 1, 2, 3, 4, 5, 6 or 7, you see that the list of parameters are 1, 2, 3 are like printed out here, like the statement is printed out here. The first parameter passed is 1 and the script name is this test.sh, right? And similarly you can use alright, there was a special symbol for printing, echoing out as a variable the list of parameters, that was @ the rate sign, right? Whereas $1 for the first parameter and $0 for the script name. Okay, so here the situation, there is a important situation, that is a condition situation. So how can we specify in our cell programming the conditions? The conditions that are mostly used are if, else and else if, and lastly you end the if by fi. So let's check the situation again. Okay, alright, so this is the basic syntax and also the most useful condition check that is used in Bash programming language. And what you do is use if space the bracket, square bracket, okay, another space. Always be careful about using this space, okay? Do not forget to put the space here, between the bracket and the command, that is if, and also the parameters passed must have a space between them. Alright, so if this command condition, okay, you terminate and then you say that apples equals to 3, else if this condition, then apples equals to 5, else you echo that unknown parameters, and lastly you end the if statement. So this is it. Okay, this is a basic syntax of how to use the if and else if bash syntax. Alright, and also there are some kind of conditions. There are huge list of conditions. These conditions are usually used for comparison purposes. So these conditions are used for comparison for many comparison purposes. Like if you can compare among the strings, and you can compare among the arithmetic numericals. So here are the basic syntax for using the basic syntax of if was the same, but here are the basic condition syntax. For example, what is the condition? How do we specify the condition in the if and inside this square bracket? The condition to check strings are equal are this one. If for the strings, two strings to not to be equal are this one, and this -n string means string is not null. This particular string is not null, whereas -z string is null. Alright, this means it is going to return true value in the case like the string is null, true value in the case if the string is not null. Alright, so just returns true whenever this condition satisfies. And for arithmetic comparison, you have to use the expression 1, that is equals to expression 2, whereas expression 1 is not equals to expression 2, whereas and these are all going to return true in the situations like this condition returns true. And also expression 1, that is greater than expression 2, expression 1, okay, greater than or equals to expression 2, whereas expression 1 is less than expression 2, and expression 1 is less than or equals to expression 2, and lastly not expression whenever the expression is false. And you guys know that to end the if statement we use fi, that is the opposite of if. Alright, so this was just about the comparison, right, for conditions. And the secondly, the important concept that we have to use while doing bash programming is the for loop. And here are some basic for loop syntax that you can see. Alright, so if you check out, I'll just show you here, and there are three most important syntax that are used, that are this one: for this variable in these situations 1 2 3 4 5 and do command 1 command 2 command and done. This is the basic syntax. And what is mean is like for variables in this kind of values, do such command. So what it does is for each variables, in value 1 it perform this, in value 2 it will perform again, in value 3 it will perform again till n, and all these commands will be executed and lastly it will be done. Whereas also you can check it, the variables not only in the numbers or values, also in files, right? And also you can check these variables or output in a Linux command, okay? And lastly you can do the command or similar situations. And this is a basic example of using for loop. Let's see the magic here. What is the situation? Yeah, text.txt. So yeah, this was the text inside this lab 8, right? My directory, only there is one text, that is, if you go and check out ls by itself, there is only one txt, that is text.txt, right? That's why it is, whenever you execute this command, the purpose was to find all the text files inside the current working directory and just echo it out, right? And just before that there was only one text, and that was text.txt. And right now you can see, guys, there is a second looping situation you can use in bash programming, that is a while looping situation. And in this while looping situation, the basic condition is this one, right? While the condition satisfies, and always don't forget to um, like put some space between the condition and the bracket, right? And do the statement, and lastly it is done. And here you can check out certain situations. And while you increment, like for in C programming you use like I++, right? And similarly you can also use in bash programming, that is I equals to dollar I plus 1. Okay, in this way you increment the counter, and this is also equivalent to this expression, particular expression, but usually this using this expression is very slower, so we prefer this. Alright guys, so for this example problem for while loop, what you have to do is you have to also include this dollar sign to implement this variable that is declared or created, right? We created this variable I equals to 1, and while using in a condition we have to just also use the dollar sign. And now let's check out the program. Let's go to the test. Okay, yeah, also I have just edited this program here. Okay, now let's save this program and let's try to run this. Okay, to run it we use this executable file. Yeah, it's working, it's just printing out. Here we go again 20 times, right? Alright, so let's clear this. Now this is it for the while loop, for using it in a bash script, bash programming language. So okay, lastly I will just try to give you some important Unix command that will be handy in case of doing some kind of complex programming. Okay, so let's see about this cut command then. You go and check out the manual of cut. What it is going to do is it just removes the selected section, okay, from each line of files. So you just try to remove the selected sections. So here is the documentation of all this about cut command, and let's implement this. The example, it says that cut something. Okay, this C, what is C means is like it just selects only this character, so you are just going to remove and just display this, select this particular character, that is character second from this text. Okay, and whereas D means the delimiter, so whatever delimiter you specify to separate the fields, right? And fields are -f, something like that. Okay, so right now we'll try to use this. Okay, to use this, what we do is first let's use this process. You guys know that process, NSF gives us the information about the current process. right? So what we do is we try to pipe this to we use the cut command, and we just display the character, the line number. We just select the text that is third. Okay, so what happens? Okay, look, if you start from here, okay, it starts from 1 2 3, so third only, it selects this third line. Okay, so it actually selects the third column, so all the column starting from third. All right, also you guys can do something like you can pipe this process, and you can cut selecting from third to the end. All right, so also this can happen. Look, from third to the end it's displaying everything, it's just selected. Whereas also you guys can pipe and cut and select from particular, from 1 to, let's select to 5. Okay, yes, Niram, this means like it's just selected from 1 to 5. Alright, so here it is. Now let's use the delimiter and the field separator. So process, file, pipe it with the cut, and let's see the delimiter as a column, and you guys can see here in the process command there is a column here. So this, if this is taken as a delimiter, all this okay, this text from here to here, okay, in a row, or in a row, yeah, and lastly as a column, it sees as a column. So all this will be taken as a first field, whereas if, like, after this and until it encounters the another column, it will be a second field. So something like so it goes on, right? And this will be the third, and this will be the fourth field. So what we want to display right now is just the first field. So let's see what happens. Yeah, I told you this till the first field was displayed. So let's just display the second field right now. Let's pipe it. Okay, here's the pipe. The delimiter was always the column, and let's display the second field. Alright guys, so you can see the second field was from 40 PTS to 00. So same thing, 40 PTS to 00, and just remove this thing, just avoid this thing, because there is no column, there is no delimiter here. That's why everything is printed, or everything is taken as a whole, as a field. Alright, so this was the simple explanation about cut command, and the magic of cut command was this one, just to particularly select the particular text or the character. Right now let's see the tr command, and before that we have to check the manual of tr, and tr means translate or delete the character. So what it does, it just substitutes or delete the particular character. Alright, and you guys can go through all this documentation by yourself. Okay, let me translate a to let's translate to z 3 4 z's, right? So whatever standard input you give will be translated. So let me give a this apple and ball. Okay, so look here, zipper and pixie. Okay, something like this. So it's you guys know that this all this was not transferred, only one character was taken. Alright, this was the situation here. So I was just trying to explain you that it will just take only one, translate one character to only one. So if a is taken, a for and Okay, expel and accents. Okay, something like this. Alright, so it's very handy, right? So you can also tell us, let me check. Yeah, I have the text. Let me get the text. What is there inside the text? It consists of something like this file. So let's translate A to Y, and let's just yeah, let's just pass the standard input, that is text file, that is text.txt. Yes, look, everything was A was changed all to Y. So wherever you see A will be replaced by Y. Alright guys, also you can use this second important translation command, that is from changing small or lowercase to the uppercase. You guys can change like this, like translate A to lowercase to uppercase, and just standard input this file, that is text.txt. Okay, look, everything was changed to uppercase, right? This was the simple magic of translation tr command. And let's go to the check about the unique command. And if you go and check out the manual, what it says is reports or omit the repeated line. So whichever lines are repeated will be omitted. So some lines are repeated, like A, B, 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 C, C, C. Okay, these lines are repeated, so this will be avoided. And just write unique text name is text.txt. Yeah, you can check that all those repeated lines are removed. Alright, so this is it for the simple important Unix commands. Alright, so this was all about our discussion about bash programming, and also the pipe, using pipe for synchronization, and using cell programming, or some we just investigated about the cell programming and some important concepts or important commands, right? So this is it for this session. So we will continue in our next session. Thanks for listening. So see you in the next